Hey guys, we are here for the last video in this chapter. This is about absolute value functions. We're here with a little bit of a different camera angle at my house today since the internet was a little bit weird at the school. Got my little holiday theme going on right there. But anyway, this lesson is going to be about absolute value, and I'm going to be honest, I'm not going to go quite in detail as much as the actual book lesson does. This might be something that we readdress maybe later on in the year, closer to the spring. But in my experience, absolute value doesn't show up on tests and assignments and the EOC tests at the end of the year quite as significantly as and in as much detail as they have in the book. So I'm just going to try to hit the high points and give us just a basic understanding today, and then just kind of know that we may go back and talk about maybe some of the more finer details at a later time, because if we don't end up getting to it, it's not the biggest deal in the world, but I do feel it's important that we just know a little bit about how we graph absolute value and what graphs of absolute value look like. So here is the parent function for absolute value. It looks very similar to the one that we use as our parent function for all of the other lessons in this chapter, except now we just have absolute value bars around the letter X. And so usually I say, well, you know what, hang on. One thing that is always true, the graphs of absolute value will always have a V shape, right? It'll be like a V like this. It could be an upside down V. It could be kind of narrow. It could be really wide. It could be wider or narrower upside down. Every once in a while there's a way, and I don't know how often this happens in our class, they could maybe even get turned sideways where it looks more like a less than sign or a greater than sign, but it's always going to change directions, right? It's always going to start going one way, it's going to hit a certain spot called the vertex, and then it's going to switch directions. So that is the most important part of today's lesson. If there's one thing that I want you to know about absolute value functions, is that whenever you see a graph of an absolute value, graphs of absolute value will always look like a letter V, or maybe even a sideways letter V, like a less than or a greater than sign. It will always, always, always have a vertex where it changes directions, right? These are not going to be lines that have a consistent slope. They're not going to be curves. It's going to go straight down, straight up, and it's going to switch directions. Okay, now if you really wanted to get into some detail here, I have a little X and Y table on how you would graph it. Now look, I picked a lot more numbers than I usually do. Usually I just pick easy numbers like 1, 2, and 3. But anytime you're dealing with absolute value, I need to put some more numbers in my table. I need to put some positives and negatives, just for the fact that absolute value is a little bit strange, and negatives end up having a, kind of something weird happen to them when you do absolute value, right? If I put -3 in there, the absolute value of -3, how many places away from 0 is it? It's 3, right? If I put -2 up here, how many places away from 0 is -2? If I took -1 and substituted it in, how many places away from 0 is -1? One spot to the left. If I put 0 in there, what's the absolute value of 0? Well, 0 is 0 places away from itself. And then the same thing happens with the positives, right? Absolute value is always a distance, so it always has to be positive when the only thing in the absolute value bars is just the variable. And so you can see how if I graph these points, -3, 3, that's 3 to the left and 3 up. -2, 2, right here. -1, 1, 0, 0. And then it's always just going to be a reflection of itself. If you know where the vertex is, right? If you can find the vertex, you can just almost flip or reflect all these points over the y-axis. So 3, 3. And so this is how it would look. It would have an arrow going this way. It would have an arrow going this way. Sometimes they'll ask you what is the domain and what is the range. And I don't know if it says that in today's questions, but just in case it does, what is the domain? The domain is how much of the x-axis does this graph use? How far does this graph go to the left, and how far does this graph go to the right? And in this circumstance, it goes forever and ever to the left, and it also goes forever and ever to the right. So the domain of this, remember the letter D is what they use for domain. It's all real numbers. This graph takes up the entire x-axis, right? It goes forever and ever to the left. It goes forever and ever to the right. There's no stopping it in either direction. The range is how much of the y-axis, how far does it go up or down? Now, this graph definitely goes up to infinity and beyond, right? It goes up and up forever and ever and ever. But it never will get lower than this point, right? This line right here at 0, right? this graph is only at 0 and above on the y-axis. So the range is going to be, I guess I put it in here, y, I don't even know if you need those braces, greater than or equal to 0. The range is, on the y-axis, this graph is all the numbers from 0 and above is where this graph kind of lives. This graph will never be below 0 on the y-axis. So if it does ask you that, I think almost every single one, in fact, probably every single one today, the domain is going to be all real numbers because the graph will have an arrow going all the way to the left. It'll also have an arrow going all the way to the right. The range will be different. The range will just be where is it on the y-axis, and then it's always going to be how many places above that, or if this was flipped upside down, it could be how many places below it. But anyway, I'm kind of getting off point. That's not really that big of a deal. The big idea I wanted you to know, it's always going to be a V-shaped, and then it's going to change direction at the vertex. The vertex is the point where it switches from going uphill to going downhill, or vice versa, right, depending on how you're looking at it. Okay, this is the parent one. Starts at the origin, or doesn't start at the origin. The vertex is at the origin, and then the slope is 1, right? Up 1, 1 to the right, up 1, 1 to the right, up 1, 1 to the right. All of these points. And then same thing here, up 1, 1 to the left, up 1, 1 to the left, up 1. Same idea. Okay, it's going up 1 and over 1, up 1 and over 1, up 1, except over here it's going to the left. That is the basic absolute value function. This is the parent function. Just like you all have parents, right? The parent function. All of the other ones that we do are going to be modifications or transformations of this one. Okay, let's look at a few of these. Put this up here. Can I do it with this board? I hope so. Transforming absolute value functions. So just like we practiced all those just in the last few days on lesson 3.6 about how they could do a vertical slide, a vertical translation, a vertical stretch, a vertical shrink. We could do the reflection over the x-axis, reflection over the y-axis. You do the same thing with these, right? And it kind of follows the same format. If you remember here, whenever you have the adding part at the end, remember what we called that on the previous lessons? We called that a vertical translation. And this is going to be 3 units up. I'm just going to put 3 up. Right? On this next one, if it's a minus something after the variable, right? Sometimes it was in parentheses, but now we have absolute value. This is a vertical translation. This is going to be 1 unit down. Whenever they include it in the parentheses, you see how on this next one with the letter J, now we have the adding 3 inside the absolute value, right? In the previous lessons, it was inside parentheses, but now it's inside the absolute value. This is whenever it's horizontal. This is whenever you're going to move the graph to the right or to the left. And remember, these are always the opposite of what they look. It looks like +3, and you would think, oh, +3 is going to go 3 to the right. Nope. It's always the opposite. +3 actually goes 3 to the left. We did that lesson a while ago, but maybe a week ago or so. And then same thing here. It's in the parentheses, or excuse me, it's in the absolute value bars. And so that's my clue that I am going to pick horizontal because it's inside the absolute value bars. And then this is going to go be a translation. And this is going to be 1 to the right because it's the opposite of what it looks. You would think -1 would actually go to the left, but it doesn't. It goes to the right because it's always the opposite. So that's how you can tell if it's a vertical translation or horizontal translation. If the adding or subtracting part is not inside the absolute value, you're going to do vertical. And whenever you say vertical, it's very straightforward. Plus is up and minus is down. If the adding or subtracting is inside the absolute value bars, you better pick horizontal. And then once you pick horizontal, something should flip in your brain to know, oop, everything's backwards. And so +3 is actually going to be 3 to the left, and -1 or minus anything is actually going to be going to the right. Okay, those are the translations, but that's not all that we have, right? Over here, you could have a number out in front that they are multiplying it by. This is a multiplying scenario, right? If there's a number out in front of the absolute value that they're multiplying by, this is when you have a vertical stretch. Now, why did I pick stretch on this one? Because the number that we're multiplying by was bigger than 1. Vertical stretch by a factor of 2 is how I would describe that. If they are multiplying by something that is less than 1, like here we're multiplying by 1/2 that's less than 1, that would be a vertical shrink by a factor of 1/2. I'm just going to put factor of 1/2. Could they do a horizontal stretch and a horizontal shrink? I guess so. I technically didn't write it on here. Horizontal would probably be where the multiplying is inside the absolute value, or something like this. Whoops, I'm not putting the letter X in my parentheses. I should be doing that. Horizontal, and I don't know if you'll get any of these today, horizontal stretches and shrinks would be inside, and remember horizontal is backwards. This is actually the horizontal shrink, and this is actually the horizontal stretch. It's because horizontal is weird. I don't think these happen very often, so that's why I really didn't put it on my board the first time. The only one that I haven't discussed yet is this guy right here. If there's a negative sign, a situation where they flipped the sign from positive to negative, this is whenever you have a reflection. Let me switch a different color so it doesn't blend in with the other purple there. This is a reflection over the x-axis. If they had the negative sign inside, that would be a reflection over the y-axis, but we are not discussing that in today's lesson, so I don't think that'll ever happen. Okay, I hope that just kind of is a review for you, right? When they add at the end, it's a vertical translation, up or down. When they add or subtract inside the bars or inside the parentheses, it's horizontal, and it's the opposite of the way that it looks. If they multiply by a number bigger than 1 on the outside, it's a vertical stretch by that factor. If they multiply by a number less than 1, between 0 and 1, that's whenever you have a vertical shrink. If they have a negative out on the outside, that's going to take the graph, instead of the letter V going up, the letter V would be flipped and the letter V would be going down like this. That's what the negatives are going to look like. They're going to be pointing down instead of pointing up. That's a reflection over the x-axis. And then the horizontal ones, I really don't think you'll encounter today, but just in case you do, that's where they would be multiplying inside instead of multiplying on the outside like we here are up here. Okay, well, I have like one more board, and I think I'm going to be done for today. Okay, what happens when they combine multiple things, right? Multiple things are happening in this one. Just take a deep breath. Don't panic. Think about what you have. Compared to the original one. Remember, the original one looks like this. We had it on our board on the very beginning of the lesson. What have they changed about this guy? Right? They've done a couple things. The first thing I notice is they have a +2 inside the absolute value. What does that represent? We just talked about it, right? When it's inside, that is a horizontal translation, and it's always the opposite when you have horizontal. So this is not 2 to the right. This is 2 places to the left. And then they have the -4 at the end, right here. The -4 at the end is a vertical translation. And this is going to be 4 down. So if I took my original graph that I made way back at the beginning of the video, could I graph this without actually doing an X and Y table? Actually, I could. Now, could you do one of these charts and fill it out and pick all these numbers and plug them in and work it out? Of course you could. But is there a faster way to do it? I think so, right? Here's our normal one. We just made it. Look what we just said. 2 to the left and 4 down. I could just take each one of these points and move them. Like I'm going to start here in the middle. Move it 2 to the left and then 4 down. Let me actually get more room here where you can see it. I just take each point. I'm going to start here at the vertex, move it 2 to the left and then 4 down. Boom, right there. And then take the next point, right? 2 to the left. 1, 2, down 4. 1, 2, 3, 4. And once you get them going, you kind of remember how it goes, right? We had these dots that were just going up 1, over 1, up 1, over 1. So it's going to go like this. And then this other side, right? 2 to the left and 4 down. 2, 3, 4 right here. And this just kind of goes up 1, 1 to the left, up 1, 1 to the left. And you kind of just have a slide of this one. You just moved it 2 to the left and 4 down. And it's the exact same width. It's the exact same orientation. It's just kind of scooted over. Okay? So we could graph these if we wanted, but I didn't think it was really necessary to do all of them. This one down here, letter, whoops, it was an H, but it got smeared there by my hand on accident. We've got a lot of things happening. We have, holy cow, they always like to start with this, the multiplying part. It's being multiplied by 2, so that's a vertical stretch. That's one thing that's happening, vertical stretch by a factor of 2. Get that on there. The fact that it's negative tells you that they have flipped it upside down. They have made it a reflection over the x-axis. Reflection, I just put reflect just because I'm saving space. They also have this -1 in the middle. What does the -1 in the middle say? -1 in the middle is a horizontal translation. 1 to the right. Remember, horizontal always goes backwards. And then they have this +3 at the end, and that's going to be a vertical translation, 3 up. Holy cow. So they did 4 different things to this original graph, right? They took our original pink line, or purple line, and they did 4 things. They stretched it by a factor of 2. What that means is they made it twice as steep. So whenever I say it was stretched by a factor of 2, instead of looking like this, and you would actually have to do the table to do this. You can't just freehand it. I'm going to freehand it, but this isn't actually how you do it. But you would make it twice as steep. So instead of being, it's going to be much more narrow, something like that, right? So they made it twice as steep, and then they reflected it. So then they took it and they flipped it down like this. And I'm freehanding. This is obviously not how you would really do it. And then they moved it 1 to the right, and so then they would drag it over here 1 to the right, and they moved it 1 place over to the right, and then they also moved it up 3 places, and so they would end up with it like way up here, something like this. Their final graph would be something like that. But you can see how they tightened it up, made it steeper, and then they flipped it, and then they moved it over, and then they moved it up. They did all these separate things, and so trying to freehand that is not going to be fun. If you really had to graph it, which I'm not going to because I'm already at 16 minutes, I would actually have taken out one of these charts and I would have written the actual formula, right? I would have actually written it out, -2, and I'm going to just copy it down, x minus 1 plus 3. And I would have actually taken my time and picked numbers, pick some negatives, pick some positives, pick whatever, and actually plugged them up in here, right? -3, if I plugged it in there, -3 minus 1 is -4. The absolute value of -4 is 4, so this is like -2 times 4 plus 3, and that's -8 plus 3, -5, right? And then I would have taken -2, plugged it in there, and worked it out, and boom, 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 do all those points, and then graph it. You get the same answer, but you wouldn't have all this just absolute mess on your hands. So I'm going to go ahead and stop right there. I did have this one last example. I'm not going to write it, but I can tell you what was going on this one, right? This has multiplying out at the front, but the multiplying is less than 1. This would be a vertical shrink by a factor of 1/2. The +4 in the middle means you have a horizontal translation, 4 to the left, because it's the opposite of the way that it looks. And then this -1 means you would move it 1 place down, a vertical translation. So we had a shrink, we had a horizontal, 4 to the left, we had a vertical, 1 down. And so when you shrink it, you actually made it wider. That one would have made this thing much more wide open. So I'm going to stop right there, guys. I'm only going to put a few questions on Big Ideas Math, or to be honest, if I don't even like the questions that are on there, I'm going to just make up my own. The questions that I give are not going to have a lot of graphing. They'll probably be more similar to this board, where you just had to recognize, okay, is it a vertical stretch? Is it a vertical shrink? Is it a translation? Horizontal, which way? Up, down, right, left? And that's probably how I will try to arrange the questions. So my little grain bin is falling down over there. Okay, I'm going to stop right there. I hope you're having a great day. I'm going to put this assignment there. It crashed again. I need some help. It fell down. So I'll put some questions up. It'll either be on the on the Big Ideas Math, not the McGraw-Hill. It'll either be on Big Ideas Math, or it will be something that I just type up. So have a good one out there. Have a good weekend, and then we'll be ready for the test and the study guide next week, and then that's it. Have a good one.